Where is the age of our solar system? How far it's extended? What we can consider as the last point of our solar system? The last planet we can see, or there's something beyond? Let's talk about that. Most of us have very blurry understanding of the solar system. We know there's a sun in the middle. We have inner planets, Earth-like planets like Mercury, Venus, Earth and Mars. And we have those giants, which are mostly made of gas and ice, outwards. The people still confused. Do we have 8 or 9 planets in our solar system? And where the end of the solar system? Let's start from the beginning. When we talk about the size of the solar system, everything becomes irrelevant. Our human understanding of the size is very objective. For us, it's even hard to grasp the size of our own planet. Only when you fly in your jet from one continent to the other, you see how vast the planet, but it's still very physically hard to judge. As they say, unless you walk it through, you can't feel it on yourself. And of course, it's related to the solar system as well. We can see the sun on the sky, like a little disk. It's hot, and it's hard to understand how far it is, what the size of it. We have quite precise estimate of the distance from our surface of the planet, the Earth, till the sun. In astronomy science, it's attributed to be the astronomical unit. And it's about 150 million kilometers, just slightly under 150 million kilometers. And of course we know the planet Earth is rotating around the sun and depends on the winter, summer, seasons, cycles of our rotation. We are closer or more distant from the sun. How much is 150 million kilometers? It's exactly as much as from our Earth till the sun. At the same time, if you think about the light travels with some delay. It takes about 8 minutes, 20 seconds to beam of sunlight travel from the sun to our surface. So this is how much is the astronomical unit is. Now let's think about that in a wider scale. So in the planets finishing with Mars, our neighbor just outside of our planet, and we have a big space between us and the next planet Jupiter, which is filled with some dust and rocks rotating around the sun. If we do all the calculations, the distance between Sun and the planets, so first Sun and Mercury, then Sun and Venus, then Sun and Earth, us, and then Sun and Mars, and then you have Jupiter. There should be the planet between Mars and Jupiter. And exactly at that point, we have big, large belt of dust and rocks and smaller pieces of the bodies rotating around. Many scientists think that there used to be the planet there, some people call it phantom planet, which crashed or blew up for any particular reason. And now all this debris is just rotating instead of the planet around the sun. And the next big giant is Jupiter, and it's located about 5.2 astronomical units from the Sun. So if you think our Earth it's 1 unit, so the Jupiter 5 times away the distance from the Sun. And it's interesting to know that the planets like ours and Mars, all those planets, they're mostly made of rocks, silicates, and metals. And the planets which are outside the belt, phantom belt, it's the planets which we call gaseous planets, Jupiter and Saturn specifically, next to planets made of hydrogen and helium. And the planets beyond, Orion and Neptune, they're made from the frozen ices, methane and ammonia and the water. So the further you go away from the sun, the cooler it's become. Of course, and it's affect the composition and conditions on those planets. For example, Jupiter, it's the next biggest body in our solar system. 99% of all the mass outside of the sun, it's in a Jupiter. At the same time, it's huge, it's gigantic, and it's have basically no surface We know there's some kind of solid core within. We know there's an atmosphere but the rest of it material is just floating there between the gas and liquid state, kind of on the critical point. So if you go on the Jupiter surface, you probably will be just in a soup of gases and liquids. Similar with the Saturn, but if you think about the distance, Saturn almost twice further from the Sun than the Jupiter. It's 9.5 astronomical unit away from the Sun. So we go very exponentially increasing the distance between planets and the Sun the further you go out. Next one will be Uranium, and it's 19.2 astronomical units away from the Sun. So next closest one was Saturn, and there's a twice more distance from previous planet. And the next one, the last we know the planet, will be the Neptune, which is a beautiful blue color, mostly made of frozen methane, ammonia and water gases. And it's 30.1 astronomical units away from the Sun. So if we think about our distance from Sun and we see the disk of Sun on the sky, it's the 1 astronomical unit. And the Neptune, the outwards known planet in our solar system, is 30 times of that. So they barely see the Sun on the sky. It must be smaller, and it's have much less light coming towards the surface of a Neptune. But what is beyond that? We know there's maybe Pluto, little tiny planets which people thinking was planet for a long time, and now people reconsider, think it's just some kind of celestial body. Outwards we have some unknown area with a lot of comets, ice, debris rotating around the Sun. So let's talk about where the age of our solar system. If we think astronomically, how you will categorize the border. Some people will think the Neptune will be the border. But if we know the properties of the star, such a big star like a Sun, we should assume that effect of all the physical properties of the Sun will be the border of our solar system. So our solar system rotating within the Milky Way, in the Orion arm of the Milky Way in particular, and it's located 27,000 light years away from the galactic center. Although some scientists suggested that our Sun is not the part of the galactic center of the Milky Way. It's actually much different, smaller galaxy which crashed into the Milky Way, and it's kind of moving in other direction within the Milky Way. We need to look in that closer. There should be more research done, and we can talk about this later. But let's just follow our standard understanding. So if you think about solar system, it's rotating in the mass of many other solar systems. So if we just think the age of our solar system will be the age where the other solar system starts, but it's not working actually specifically like that, because there's a huge amount of space between the solar system. Next thing, as I said, will be to look at the effect of the Sun and how far it reached. And we know that the Sun reached its solar wind, the energy that coming from the Sun, particles, protons, heat, any other waves, microwave, infrared waves, all type of waves and radiation coming from the Sun, and it can reach quite far. And scientists found that also the gravitational pull of the Sun towards the center of the solar system. So it's logical to think when all these properties finishing, that will be the age of our system. So let's have a look, where is it? So after the Neptune, 30 astronomical units, we have about another 20 astronomical units distance radius is a Kuiper Belt. This belt where we have a lot of half of the billion objects like frozen ices, methane, ammonia, like little particles, little rocks, and so on. A lot of comets and asteroids rotating in this Kuiper Belt. But outside of the Kuiper Belt, scientists find Oort cloud as well, and the age of the Oort cloud will be actually the furthest age of the solar system, where the effect of the solar system stops, and we have the effect of an interstellar medium, which is the space between the solar systems. So our cosmological kind of border of the solar system will be some assume Kuiper Belt outside of 50 astronomical units. That's where we have everything within will be pulled by the solar gravity, will be affected by the properties of the sun. Everything in the Oort cloud will be like a cushion between solar system and outside world. So if we have other solar system coming closer to our solar system, they will interact in this Oort cloud. And this Oort cloud spread from 2,000 astronomical units to 200,000 astronomical units. You can imagine how huge this large border outside of our solar system. It's filled with billions of comets. Many of them interacted, some of them dragged and pulled by the sun into the solar system. So here we go, there'll be the age of our solar system, more physically affected 50 astronomical units, and we have Oort cloud, it's kind of like a cushion in between, which is spread up to 200,000 astronomical units. So for understanding of that by humans, for a grasp of our understanding of these distances, it's enormous. It's so enormous, it will take long time before we'll get there physically, using robots or so, or even ourselves. At the same time, it's comforting that we have such a good cushion of protection from whatever is there in our Milky Way or outside of it, and they give you understanding how unique our solar system. And it's like a big balloon, very cushiony protected, the very important center of this balloon floating around the space.